Welcome to Understanding Applied Statistics, Processing with SPSS, Chapter 4, T-Test. In this module, we'll take a look at technique for comparing two groups consisting of continuous variables. This is the T-Test, one of the most common and versatile statistical processes you'll encounter. When we look at the classic two-group design, we typically think of Group 1 as being the control group and Group 2 as being the treatment group. When we have a two-group configuration like this, when it comes to comparison, there's really only one comparison that could be made. We can compare the mean from Group 1 to the mean from Group 2. To take a look at this graphically in terms of the t-test, we see the mean from Group 1, the mean from Group 2, and our comparisons mean that we're simply going to compare the mean from each of the groups, Group 1 to Group 2. For our example, let's consider an agricultural experiment, two-group study. Group 1 will plant a row of corn, 10 stalks, and will feed it water. In Group 2, we'll use a promising new growth agent called crop charger. We'll plant a separate row, 10 stalks of corn, and we'll administer crop charger. And we'll measure the heights of each row after a month and see how they do in height. We'll see if there's a statistically significant difference between the means from Group 1 to the means from Group 2. Let's take a look at how this will process in SPSS. Here we have our two variables set up to run the t-test. Group, which is a categorical variable. I'll reveal that 1 signifies Group 1, the control group, and 2 signifies crop charger, Group 2. So we take the 10 entries from Group 1 and enter the heights from those corns. We then go over to the second row and collect the data on the heights that were rendered from the crop charger group. We'll then go to Analyze. We go to Compare Means, one-way ANOVA, and for group, we'll load that into factor, and for height, we'll load that into the dependence list. Options, we want to see the descriptive statistics. In particular, we're going to be very interested in the means. And so we'll also select the means plot so we can get a graphical representation. We click Continue, and then OK, and it processes. Now here's what we see. For water, Group 1, we had an N of 10 and a mean of 34.4. For the crop charger row, there were 10 stalks of corn and the average height was 38.8. And the main question here is, are these differences statistically significant? For the answer to that, we come to the ANOVA table and we observe the SIG value, significance, otherwise known as the p-value. And we see that the SIG figure comes in at 0.029, which is less than the traditional alpha level of 0.05. So we would say that the difference between water at 34.4 and crop charger at 38.8 is statistically significant difference. We can also see this represented in the means plot. Here's water at 34.4 and here's crop charger at 38.8. This concludes this module.